Okay, it
Okay,
says, oops.
go ahead, Lauren.
Right. Okay. A function that has a pattern of y values that repeats at regular intervals of its domain.
Good. Can you read me the very last part again?
Yep, that repeats at regular intervals of its domain.
Good. Okay, so something that is periodic repeats. So you guys heard of like the periodic table in science class. It's called the periodic table because the pattern repeats with the electron shells, with the number of valence electrons. There's a repeating pattern that you can use it to interpret future predicted behavior. So anything that has a periodic pattern to it is a periodic function. So examples would be in real life, sunrise and sunset. So you guys know as we approach the mid-June, we're getting more and more sunlight in our day. As soon as we hit the summer equinox, then we start getting less and less sunlight until we hit the winter equinox. There's a repeating pattern, and people in science use that when they predict what the sunrise is going to be tomorrow or the sunset. It's a periodic repeating pattern. Tied in and tied out, periodic repeating pattern. Okay, so anything that has a pattern that repeats at regular intervals is a periodic function. Okay, Bella or Alexa, can you read cycle for me, please?
I can read cycle. One complete pattern of a periodic function.
Good. So one cycle. So let's think about Earth's position in orbit, how far we are from the sun. One cycle is 1 year. So we go from January 1st to January 1st. Okay, so a complete pattern of that periodic function. What is the definition of a period? Bella.
Sorry, I am looking for my textbook. I know it's here somewhere, but I just cannot find it. I am literally searching throughout my whole room, and I'm really hoping I didn't lose it. So
Okay.
just give me like 5 minutes, and I'm sure I'll have it found. You might want to skip over me.
That's okay. Don't worry about it. Lauren, can you read that one for me?
Yeah, it's the horizontal length of one cycle of a periodic function.
Right, good. I'm struggling to spell here. Let me change these. So it is the horizontal length. So if we were graphing it, you would see when does the pattern start and when does it stop and then repeat again. So a period is the length of one cycle on a graph. So for Earth in its orbit, the length of a cycle, its period would be 365.25 days. That's the length of a period. And then we start again. Okay, so the period, it says horizontal length because we're thinking it's on a graph and we can see it. Alexa, how about amplitude?
So amplitude is half the distance between the maximum and minimum values of a periodic function.
Okay, good. Usually, if we hadn't translated the periodic function up or down at all, usually you can just go from the x-axis. But if it has been translated up or down off of the x-axis, then you take the top and you take the bottom, the highest point and the lowest point, add and divide by 2. So do max plus min, whatever that equals, and then divide by 2. I'm gonna do it like that. Max plus min, divide by 2. All right, so today basically we're exploring these main concepts. Does anybody need that page any longer?
Mommy.
Just a few seconds.
Let me know when you're ready, Makai. Anyone else need a minute? Okay, so let's look at a couple of examples here. This is how can you identify a graph that represents periodic behavior? The graph shows the predicted height of water at Hopewell Cape in New Brunswick during high and low tides for the first 7 days of May 2007, beginning at midnight on May 1st. So you've got this graph here. Number one says describe the graph. How would you guys describe this graph? Anyone can go ahead and unmute themselves and just tell me what do you think?
It
Nobody-
kind of doesn't look like there's that much change.
Okay, it's definitely a repeating pattern.
Yeah.
Ups and downs, right? Maximums and minimums. I guess maybe it looks like a wave, like it looks like waves. Can we say that? So we're just looking at this graph. You can see it, it kind of looks like a spring oscillating to me, like it goes up and down and up and down. It just keeps going on and on. It says this graph illustrates periodic behavior, which is regular and predictable. Can you look at that graph, guys? And what do you notice? How can we tell it's regular and predictable?
Because it's repeating.
Very good. What's the highest it reaches during the first part of the pattern?
Hey, Mama, can I eat these now?
Like 10,
hard
12
to-
point something, 11.
Yeah,
Yeah,
and
I
then it
have no
goes,
idea.
yeah, it's hard to tell on this graph what the scale is, but then it goes up slightly higher at the second peak and then down back again and then up again and down again. So that pattern is repeating. It always hits the same values, right? So the graph, oops, sorry, has repeating points. Like you guys could predict, this is a lot like predicting patterns in elementary school. You guys could predict how to continue that pattern going because it literally hits the exact same points as it progresses from left to right across the graph.
Can Leanne get 5 gummies too?
The second part of the question said, why are tides considered to exhibit periodic behavior? Why are tides considered to exhibit periodic behavior?
Because they're pretty much the same each time.
Yeah, exactly. Number 3, consider the portion of the graph from midnight on May 3rd, which it says is T2. So follow the line up here at T2 to T3. Consider the portion of the graph from midnight on May 3rd, so from T2 to T3. What's the maximum high of the tide? What's the maximum value at T2? We're gonna have to just estimate. T2, right here. What does this look like?
Like 11.75.
Yeah, what is this going by? So if it goes by 0.25, everyone is 1.25. So this is 11.25. So what are we thinking is right about here?
12.
12, let's say approximately 12, because that's a hard thing to estimate. So we'll say approximately 12 meters. Okay. Actually, I'm going to show you guys in a math symbol, the symbol for approximation is a squiggly, that means approximately. So I'm going to do that for approximately 12 meters. That was A, 3A.
Mommy.
Okay, let's see what's part B here. Okay, 3B. Did I do all of 3A? Actually, let me check. Yeah, what's the minimum value between T2 and T3? So what's the minimum value? So I'm going from T2 to T3. What's the minimum value that we see? It looks like about here. What does that look like, guys? I think it's straight on 2.5. Does that look about right to you guys? Silence means yes, Mrs. Reed. You clearly are right. Thank you, Makai. Okay, 3C. What is the time between the high tides? So go from a peak to a peak. It doesn't matter which two you pick. Go from peak to peak. So maybe I'll pick this one here. What's the length of time between these two peaks?
1 day.
1 day. Good. 1 day. All right, let's see what's next. Oh, these are all part of 3A. Okay, hold on, I'll change that. What's the time between the low tides? So let's go back up here. Let me pick 2 low tides. So we did pick this one here. I'm gonna go into here to this one. What does it look like, guys? What's the time between the low peaks?
1 day.
1 day. 1 day. Okay, so this was actually 3. I'll change it. You guys, hopefully you guys have it in the right spots. What would be one complete pattern? What would one complete pattern of the graph represent? What would one complete pattern of the path of the graph represent?
1 week.
So just follow one complete pattern, not the whole graph. So they're asking you pretty much for a cycle here. What does a cycle represent?
24 hours.
24 hours, yeah. Or 1 day. If you looked at the whole graph, Makai, then that would be a week. Yeah, because it goes for about 7 days there. So that would be good if they asked you for the whole graph. Number 4, give 3 other examples of periodic behavior. Explain what makes them periodic. Let's just brainstorm quickly. What have I previously said, or what do you guys know as far as pattern that is periodic or repeats?
The moon and the sun.
Good. So position from the moon. Actually, maybe I'll put Earth's position from the moon. Earth's position from the sun. I'll put sunrise, sunset. 1, 2, 3. One more. Oh no, we got 3. We got 3. Alrighty. So that was just basically looking at the graph there and the periodic behavior demonstrated by the tides. Number 2, identify the graph of a periodic function. All you're doing in this question is seeing, is it periodic or not? And if it is periodic, we're going to look at the period, the amplitude, and also the domain and range. We're pulling in some knowledge from our previous units. So what are you looking for to determine whether it's a periodic function?
If like the line is consistent.
Tell me more about what you mean there, Makai.
Like for B, the line stays the same. It goes up and down in the same motion like a bunch of times.
Okay.
But in A, it's like going at different rates, I guess.
Exactly. So you're looking to see if the graph repeats exactly the same. So Makai, you said that A is not a function, a periodic function. Sorry, I'm going to be specific here. It's not a periodic function. If you guys look at this graph, it goes down to -2, up to 2, down to negative, let's say 1.5, up to just over 1, then 1, 1, about 0.75, negative 0.75, positive 0.75, half. The actual height of it is decreasing over time. This would be like if you took a spring and you pulled it down and let it go. It goes to its maximum and then it slowly slows down, and that spring is extending less and less over time. That is not a periodic or a repeating pattern. So A is not a periodic function. Okay, we don't have to do anything else with it because it is not. That's it. Yes, Lauren.
Is what you're writing right now, is that what we're supposed to write in this thing here?
Hold on 1 second.
Like this?
Oh, I have a graph there. Yeah. Yeah, actually for that one, you can just cross it out and say not a function.
Okay. Thank you.
You're welcome. I forgot I added that chart there. I'm going to open my notes too so I can see it. Guys, if it's not a function, you can't determine the period, the amplitude, the domain, and range because it changes over time. So just for A, put not a function, cross it out. Good question. Okay. However, Makai, you said B has a repeating pattern, right?
Yeah.
Okay, so we do have to fill in the chart for part B because it is a periodic function. So yes, it's a periodic function. I should have given myself that chart. All right, now what we have to do though is we have to figure out the period, the amplitude, the domain, and the range. Okay, what do we mean by period, first of all? You guys may have to look back in your notes there. What does it mean for period?
The horizontal length of one cycle.
Okay, we're looking at the, very good. We're looking at the length of one cycle. So what I want you guys to do is just pick us a point. Doesn't really matter what point you pick. Pick a point and then see when does that point, that pattern repeat again. So I'm maybe going to start, I was thinking about starting at 0. Yeah, sure. Why don't we start at 0? I'll start right here. Or actually, maybe this is the easiest down here. Follow with me, guys. I'm right here at this lowest point here. Then it goes up like a mountain, down, up a bit, and then it's back down to here. And then it goes up like a mountain, down, up a little bit, down. Okay. So what is the length from here to here? Actually, this might be hard to see. Maybe we should go by the zeros. Let me do that again with the zeros, because those are not whole points.
Oh.
Yeah, hold on 1 second, Lauren. I'm actually going to go by this 0 pattern. The trick about 0 is make sure you go to this point at which it's repeating. So up, down, up a bit, down, and then here's where it's on its way up again. Don't pick this 0 because that's not the full complete pattern. So just be very careful with this one. How long is it before the pattern repeats again? What's
3.
the length? Don't go by ones though, Makai. Look at your scale.
Oh, 6.
Good, it's 6. It goes by 2s. Good. So the period is 6. And I don't know what this means. It doesn't tell me if that's days, if it's hours, months. Okay, so I'm just going to put 6 on there. It repeats every 6 units. Okay, amplitude. What's your definition of amplitude in your notes?
Half the distance between the maximum and minimum values.
Very good. Okay, so what you're going to do for this is you're going to take your highest value, which is 4, and your lowest value, which is negative 1, 2, 3, 4. So this, the y-axis is going by ones. 1, 2, 3. I think it's negative 3. So is that negative 3, guys?
Yeah.
Okay, so you're going to do 4 plus 3 divided by 2 to figure out what's the amplitude. What's this amplitude?
Wait, how come you did +3? Isn't it -3?
Oh, thank you, thank you. 4 plus negative 3. Lauren is on the ball today. What is your amplitude?
½
Perfect. 4 plus negative 3 is positive 1. divided by 2 is 1/2. Oh, that's not what I wanted to happen. Amplitude is 1/2. Okay. All right, guys, now we also need to think about domain and range. Domain is the x value where this graph exists. Does this graph show us that it ever ends?
No.
No. So what's your domain for this?
XER.
Yes, XER. You guys remember that? All real numbers. I'm not sure I can do, I'm gonna have to just handwrite it. Let me just handwrite it. If it's a periodic function and I haven't said where it's starting or stopping, you guys can assume it goes on forever because it's a repeating pattern. Okay, so XER. If it was something where it was like maybe I was in business and I had started in January and I was ending something in June with a repeating pattern, I'd have to tell you start and stop. But most of the time it's just going to be continuous. Okay. What does range stand for? What does range start?
Only like
stand
all
for?
real values y can have.
Yep. And are there limitations on the highest and the lowest value of y for this one?
Yes.
Yes. What's the highest it is?
4.
And what's the lowest it is?
-3.
Very good. So if I was going to write this, and we can use the same notation as quadratics, it's going to be all real numbers. Start with the smallest number, -3. Y is greater than and equal to -3, but is less than and equal to 4. So lowest number first, highest number last. And just go off of the graph. What's the highest and what's the lowest? You would have already identified it because of amplitude. So lowest number first, highest number second. Hopefully you guys can read my handwriting there. Lowest number first, highest number second. And again, you will only be describing period, amplitude, domain, and range on graphs that are periodic. So if immediately you decide it's not periodic, don't analyze that graph, just move on to the ones that are periodic repeating graphs. Any questions on this one? So far, so good, I'm hoping. All right, this one says find periodic function values. Y equals f of x is a periodic function. They're telling you this is periodic. It has definitely a repeating pattern. Find the value of f of 0 and find two other values where it has that exact same value of 0. So this sounds complicated, but it basically they're asking you to find on the graph where is y equal to 0. You can see it happens quite a few times because it's a repeating graph. So where is a value where y is equal to 0? Or x is equal to 0. You're on the x-axis. I said that backwards. Where are you on the x-axis?
-1 and 0.
Okay.
Oh, just using
it's
yeah,
not
0.
going. Yeah, it's not going by ones. Good. So it is 0.5. So you can see I have one here. I have one here. I have one here. I have one here, here, here. So Lauren said there's one at -0.5. Where else do you guys see those points?
-1.5
Good.
and then -2.5.
Good. Also, you could say positive 0.5, positive 1.5, positive 2.5. There's a lot of these values. So you're just looking at where does it hit the x-axis and grab any of those points. Now it's asking you to find where x equals 0.5, which is along this line. So here, 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 here. Is x 0.5? So you could record any of those. They're hard because they're not on whole number values. But we could estimate them. It's very close to the same because it's just gone slightly up or slightly down from the 0. Or I'm just going to put here green points on the graph. All right, what is the domain and range of this function? What's the domain, first of all?
X here.
Good. It even has arrows on this graph. So I know it's a repeating pattern, but it also tells me it's going to infinity and beyond on both sides of this graph. It's just going to keep repeating. Okay, so all real numbers. How about the range?
YER line -2.
Very good.
Yep, that one. And then Y is that one +2.
Perfect. Guys, your arrows always point to the left. Okay, so put the smallest number, and then that is, and it's first saying that Y is greater than and equal to -2. And on the right side is saying it's less than and equal to +2. So it's +2 and everything lower, but only to -2 and then higher. So it's between -2 and 2 is what that's saying. Okay.
So it'll always be that way?
Yes.
Okay.
All right. Here is the keynotes from what we've done. A periodic function repeats the y values at regular intervals. The period of the function is the length of one cycle. We measure that along the horizontal axis because that's typically time, or it's definitely our independent variable that we're measuring on the x-axis. Amplitude, take the maximum and the minimum, divide by 2. Like that's that. Period, amplitude, everything's there. Any questions so far?